I'll now define the null space of a matrix. We're going to let A be an m by n matrix. The null space of A is denoted by NUL of A. The null space is the set of all solutions to the system AX equal to 0. And this is a subspace of Rn, so that's determined by the number of columns of this matrix. Here I have a matrix A and a vector B, and I want to know, is B in the null space of A? So what that's asking is A times B equal to 0, since this is how the null space is defined. So in order to do that, we'll set up my original matrix A, and then multiply it by B and see what happens. So B is -8, -9, -4. When we multiply this, the very first entry will multiply the first row by the vector. So we have 6 times -8, which is -48. 4 times -9 is -36. And 16 times -4 is -64. And we can go ahead and work this out, but I'm not going to go any further than that because we can definitely say that this is not the 0 vector, since that first entry is not 0. So no, this vector is not in the null space. I now have my matrix A in the reduced form of A, and now I want to find a basis for the null space. So this means I'm looking for AX equal to 0 and its solutions. My first step in this is going to be to fully reduce A. So right now it's in a row echelon form. I need it in full reduced row echelon form. And if I do that, this right here is the matrix that I will get. From here, we'll write down our equations. That first row says x1 plus 3x2, and we want these to be equal to 0. The second row says x3 is equal to 0, and the third row says x4 is equal to 0. We want to solve these for where my pivots are, so we want to solve them for x1, x3, and x4, since that's where my pivots are located. Now that I have that, my actual vector looks like x1, x2, x3, x4, since there are 4 variables here. And then I'm going to write in what I just learned from these equations. x1 is -3x2. x2 is a free variable, so I'm just going to write x2. And then x3 and x4 are both zeros. We can factor out the x2, and we get -3, 1, 0, 0. So this vector right here is the basis for the null space. So the dimension of the null space of this particular matrix is going to be 1, since there is one vector here that defines the null space.